You sharing, right?
Yeah, once I'm just. Okay, can everybody see the screen?
Yes.
Yeah.
I mean, there is a um, there is some little block on the right top corner.
There is a
So
gray block on the
yeah,
top right corner.
yeah. Now it's okay.
Okay. Um. Okay.
Still there.
Second, let me figure out how to.
Yeah. Go ahead.
Wait, wait, wait. Um. Yeah. So everybody can see my slides now, right? Just confirming.
There's another block on the left hand side.
Okay. Okay.
Yeah, maybe it is the Skype window or something.
Sorry. Let me just leave and join again. That might make it better.
No, I mean we are able to see your slide, but they are covered by something else.
Yeah. So that just I'll just do that 1 second. Okay. Let me try.
Yeah, go ahead.
Uh. Sorry for the technical issues again.
Yeah, I don't know. There is some issue that he's facing. Sorry about that.
Okay. Now can everybody see it?
Yeah,
Is there a block or anything?
no, it's fine now.
Okay, so yeah, as I was saying, we touched upon uh, the concept of limits last time, but now I'm going to, make more definitions because calculus requires some definitions. And well, the limit is, well, we can use the limit to define the concept of increasing a value further and further until it reaches some point. So yeah, if you remember, we did the um, area, how to find the area of the circle, and for that we we did we increased the number of sectors we made until it became until we could say it, you know it approached a rectangle, and we know how to find the area of a rectangle, right? So um, this this is just a way to formally say that. We say that as n tends to infinity, n is the number of sectors in the circle, the area tends to RC by 2. And yeah, and you can see at the bottom, that's just how one way to write it. Limit as n tends to infinity of a is equal to RC by 2, and both of these mean the exact same thing. There's two different ways to write it. And the the way on the bottom is definitely more common, but the way on the top is not really wrong. So yeah, now I just want to say a little something. In the previous example, the n, right, was tending to infinity. However, it does not have to tend to infinity. Yeah, that's just a little something I wanted to point out. Okay. Now, I'm going to introduce a new concept, which is the limit of a function. Now, when we try to find the limit of a function, we're trying to find the value that the function approaches as the function's, the input of the function approaches a specific value. Now, this specific value, we can call it C. I think, yeah, we'll just call it C. And what I'm trying to say here is that we don't really care about the function's value at C when we're taking the limit. We care about the value it approaches, the value it gets closer and closer to as the input approaches C. And it's regardless of what the value is at that point. It really doesn't matter what the value is. The limit doesn't take into account the value. They're two distinct things. And I have a few examples ahead to illustrate this, but this is an interesting point. So if you have a comment or question, just you can unmute whenever you want. You don't need to raise your hand or anything. Okay. 1 second. But yeah, so before we do this, however, I want to just make an important distinction that
I can't hear you, Apurva.
all right. You can hear me?
Yeah. Go ahead.
You can hear me now, right?
Yeah.
All right. Okay. Yeah. So I was saying that I just want to make a clarification. We'll see these two different symbols ahead, but I just wanted to make a distinction between them. The one on the left is an open circle, and the one on the right is a closed circle. Now, when you see an open circle on a graph, as you'll see ahead, it means that all points around the circle on the graph are included in the graph. That means they're defined by the graph, right? But the point at which the circle is not defined it's not defined by the graph specifically. Basically, however close you get to the point with the circle, say point P, okay? However close you get to point P, you'll have a point that's on the graph, but point P itself will not be on the graph because it's an open circle. But with a closed circle, we know that point P is on the graph. It's defined by the graph. I can, these graphs will help a little. They're both graphs of the function y equal to 2, except the top graph has an open circle and the bottom graph has a closed circle at the point 3, 2. Now, yeah, the value of either graph, right? You choose the top one or you choose the bottom one. Either graph will be 2. Uh, re- regardless of what value you choose, whether it's 2, and even as it gets closer to 3, like 2.5, 2.9, 2.99, or like even like 2.99999. However, close to 3, you choose the x value, you will still get a y value of 2. However, if in the top one, if you choose an x value of 3, the value of the graph, or really the value, yeah, the the value of the graph at that point will be undefined for the top graph. But for the bottom graph, since it's a closed circle, it it will also be 2. Yeah, just wanted to make that clear. Is that clear for everybody? I think we probably heard of this in school, but just making it clear because I'm not sure. Everybody got that, right?
Sounds good. Yep.
Okay. Now, we cleared up an important convention. Now you can see it used in this graph actually. But now I want to see some different limits. Now, suppose we have the function that's shown here. What would be the value at x equal to 1.2? And just, you don't need to calculate it, an expression would be good enough even. Anybody? The value of the function at x equal to 1.2?
E raised to 0.48.
Yeah, perfect. And value, but now what would be the limit at x equal to 1.2? Limit of the function as x gets closer and closer to 1.2. Yeah, go ahead. Um,
1.7 maybe.
1.7. Are you doing that based on the graph?
No, just intuitively.
Wouldn't it
Why?
wouldn't it just be e to the 0.4 in a 1.2, because as x approaches 1.2, it like infinitely approaches it. So and since like the graph is continuous, you'd like just say that the limit is e to the 0.4 in a 1.2.
Yeah. Yeah, that's yeah, now you bring in this concept of continuity, which is, it's a great concept. But the main point is that since it um, tends to the same point, that is, it approaches on either side of x equal to 1.2, it approaches that point that is on the graph. We can say that the value of the graph is, since it approaches that value, which is the value of the graph, we can say that the limit of the graph is the same.
I mean, I think the value of function, perhaps.
The value of the function, yeah, that's a better way to put it. Definitely.
So, I mean, Apurva, can we say that we are just lucky that the value of the function and the value that the function approaches as x approaches 1.2 are the same?
Yeah, we can say that we're lucky because that does not happen all the time, for sure. as we can see in this example. Now this is an interesting function. X squared minus 4 by x minus 2. So I want to know what would be the value of the function at x equal to 2.
Go ahead, Shashwat.
Is it 4?
4. Why do you think so?
Well, first of all, the function can be simplified. X squared minus 4 over x minus 2 is the same thing as x plus 2. And since x is 2, it's just 2 plus 2, which is 4.
Okay, but now we have a function here. Although the expression x squared minus 4 by x minus 2 can be simplified to x plus 2, is the function x squared minus 4 by x plus 2 the same as the function x plus 2?
Yeah,
The fun-
that's a good question. I think Swara has also raised hand. Swara, you want to say something?
Yeah, I think it would just be undefined because if you put in 2 into the function that we're given, the denominator would be 0. So it just has a hole at that point. But otherwise, the two functions would be the same.
Okay, that's an interesting idea too. But so it's a good question though. Why is it not? I I do believe that it is undefined, but the question is why is it not 4? Because obviously you can simplify x squared minus 4 by x minus 2 to x plus 2. But are the functions f of x equal to x squared minus 4 by x minus 2 and f of x equal to x plus 2? Are those two functions equal? Are they the same function? So yeah, it's an interesting question, but by definition, we say that two functions are the same when their domains and their ranges are the same. The domains and ranges have to be equal. Now, the is the domain and range for each of these functions the same?
No, because this function has a denominator. So there's a value where for x where the denominator is 0, and we can't have that. So the domain is like all real numbers except 2.
Yeah. The domain, or you can say really that the range does not. I mean, yeah, actually, what you said is correct, definitely. So what do you think? Do you still think that the value of the function is 4?
No.
Okay. So what do you think the value is?
Arav wants to say something.
Oh yeah.
Could we say that the value tends to infinity? Like since the denominator is tending to 0, the value keeps on increasing, right? So when it is 2, it's undefined, but can we say it tends to infinity instead of it's undefined?
I'm not sure. Try what if you tried with 2.1, and then you reduced it to 2.01, 2.001. You think it would go to infinity? It would increase arbitrarily?
It won't. It won't, because the numerator is will become negative, right?
Yeah. So
Right.
yeah, the problem, the point, the thing is that um the when you have a 0 in the denominator, things get complicated. When you have a 0 in the numerator too, things get even more complicated. So we can right now we don't know whether a 0 by 0, right, if the value at x equal to 2, right, when we consider, when we just find the value of a function by inputting x and we plug the value of x in to each x in the function, right? And evaluate the function. When we do that, we get some value. But in this case, we get 0 by 0. Now, we don't know yet whether 0 by 0 is infinity or not. So I think it would be safe to say that for now, since we don't know what it is, 0 by 0, we can just say that it's undefined. Usually we know that dividing by 0 is undefined, right? So can we just say that 0 by 0 is undefined? So wouldn't that make our value at x equal to 2 undefined?
Yes.
Okay. Now, yeah, that's so now that we've established that the value at x equal to 2 is undefined, what would be the limit of the function at x equal to 2? Now, you can, I guess in this case, you can look at the graph, and that it's a good visualization. It helps you see what value it approaches. But remember, the value is at x equal to 2 is undefined. So what would the limit be?
Swara, go ahead.
I think the limit would be 4 because the left-hand side of the graph and the right-hand side values are both like tending to 4. But at 4, it's at 2, it's undefined.
Yeah, at
So
2
you
is
think that the
undefined.
limit is 4?
Yes.
Okay.
Does
How
anybody
about you,
else think
Ashwin?
otherwise?
I think Ashwin also raised his hand.
Yeah, the limit will be 4 because both from the left side and right side, you're infinitely approaching 4, even though you do have a removable discontinuity at x equals 2, you'd still the limit would still be 4
Because you're saying because you approach.
because you infinitely approach it from the left and right side, even though it's
Okay.
not continuous at x equals 2.
Yeah. Okay. So
So
that
it's
seems
not continuous, but it's not continuous, but its limit is still 4.
So limit
Yeah.
exists even though it has a hole or a discontinuity at x equal to 2.
Mm-hmm. That seems like a good explanation. And so we have some people that think it's 4. Does anybody else think otherwise? Okay. So I think nobody else thinks otherwise. Okay. So yeah, the limit at x equal to 2 is to, oh my god, sorry, I meant 4. It's that was a typo on my part. Limit at x equal to 2 is 4. Because and it's because even though at x equal to 2 it's undefined, it does approach 4 from either side. So but we can just say that the value of the function approaches 4 as x approaches 2, even though at when x is 2 it's not defined, right? Pretty much what both Ashwin and Sweta said. Okay, so as we saw in the previous example, the limit and the value may not be the same. But in the previous example, it was undefined, the value of the function. But even if the value of the function is defined, the limit can differ from the function. As we see, the limit can differ from the value, I meant, as we see here. Now, this is a peculiar function. This is a function I defined as f of x is equal to x cubed, okay, unless x is equal to 1.5, in which case f of x will be 1.25. So otherwise it's for every single value except x equal to 1.5, f of x is x cubed. But for x equal to 1.5, I've given f of x the value of 1.25. Now, so what would be the value of this function at x equal to 1.5?
$1.25.
Yeah, because I defined it that way. Good job. But now, what would be the limit of this function as x tends to 1.5? Again, the limit, we're looking for the value it approaches. The function approaches as x approaches 1.5. We're looking for the limit of the function, which, as we've seen before, it may be the same as the value of function, but as we've also seen before, it may not be the same. So does anybody know limit of the function?
I'm gonna say a guess here, but I think it's 2.25.
2.25?
Yeah.
Why do you think 2.25?
Because there are instances where the function is also 1.5, but and in the function, like both sides are approaching 2.25, even though it's undefined.
Is it 2.25? Because it's f of x equal to x cubed, right? So
Oh, never mind. Whatever 1.5 cubed is.
1.5, you don't have to calculate it. Again,
Yeah.
the simple expression 1.5 cubed is
Yeah.
perfectly fine. And does anybody think otherwise? Is there any other answer? No? Okay. Okay then. Yeah, the limit at 1.5 x equal to 1.5 is 3.375, which is 1.5 cubed. Now, so far it's mostly been visual. We've seen that it approaches this some value, which is called, well, the limit of the function. So, but this and we've also seen that this value that the function approaches may not be equal to the value of the function. So, but I mean, and so we see here that this value approaches x cubed, even though the value of the function is not x cubed. And in the previous examples, we saw it approached 4 x squared minus 4 by x minus 2. And it approached, for the first example, we saw it, in that case, it did approach the value, right? It was e to the power 0.4x, I believe. Now, so we've seen all these different things, right? The difference, mostly the difference between the limit and the value of a function. So are there any doubts on that? Does everybody understand that pretty well? Because what I'm going to show you next is really interesting, I think.
I understood how the limit is 3.375. I don't understand how x becomes 1.25 at 1.5.
Yeah, so if it was just a simple f of x equal to x cubed graph, it would be 1.5 cubed at x equal to 1.5. However, I have defined, okay, I have defined that the value of f of x when x is 1.5 will not be 1.5 cubed. It will just
Okay.
be 1.25.
Okay.
Yeah,
Got
so I
it.
mean, sometimes this is called the definition by cases, right? You say that,
Yeah.
okay, you perhaps have seen that when x is less than 0, f of x is something. When x is equal to 0, it is something. And when x is greater than 0, it is something else. So, there's a big curly brace. That's called the definition or function definition by cases. So here, uh, just you can bend it to your whims. And so what Apurva is saying is that f of x is x cube. I mean, f of x is equal to x cube if x is not equal to 1.5 and it is equal to 1.25 otherwise, which means that then it is x is equal to 1.5.
Yeah, so just definition by cases, also known as piecewise definition of functions. So I defined for some pieces of the function, the I define it differently from a different part of the function. So yeah, either way, it's
But I mean, I think the point is that in all these cases, in all the, cases in which functions can be defined in any which way, we have to have a satisfactory and consistent answer to calculate the limit. I think that is the point that he's trying to stress.
yeah. So yeah, now I just want to make sure before going on to the next thing, everybody's comfortable with the idea of limits, basically. Yeah, everybody is.
Yeah, I think we are good on this, but a time check, maybe we should wrap it up in another 2-3 minutes, Apurva. So maybe you
Okay.
should go.
Now,
Yeah.
yeah. So this this is a really interesting function. Just look at it. Like what? Like the first thought that comes to mind. What in the world is happening to this function? So
You plotted
this,
this on GeoGebra or something?
yeah, I plotted it on Desmos, but yeah, it's a little difficult to understand. If you would like to plot it yourself, just go to Desmos graphing calculator or GeoGebra graphing calculator to, explore it further, and that it really helps actually. But it looks like a very crazy function, and it is signed 1 by x. Um, so what happens is the um, input gets closer to 0 is the question. Like not as a limit, just qualitatively, what happens as um, the input gets closer to 0. I don't want to know the limit yet. I just want to know what you think. Like, what at first glance, what do you think happens? What do you think is happening to the function as it gets closer to 0 from either side?
I think when it gets closer to zero, sine one over x for like a bunch of values that are also close to zero is approximately the same.
Um, I didn't really get what you're saying. Sorry.
So for example, like if the input is like 0.1, 0.2, and so on, then the sign of values such as those is the same for because like
Yeah, maybe you can show some actual values, Apurva, if you have calculated
Yeah,
them.
yeah. This is a really interesting function because the biggest thing that happens with this function, right? When qualitatively speaking, what happens to this function is that it just starts oscillating, and it's a this function is oscillating. You can see a sign in it, which means it's a periodic function. But this starts oscillating faster and faster as it gets closer and closer to zero. Right? Can we see? We can see that, right? Like it it might not be as easily discernible as you get closer and closer, but at least we can see the general trend of it is, I mean, that it's becoming, it's oscillating faster and faster, oscillating about the x-axis faster and faster. And so this is, so to help visualize, right? Actually, I made a table of the values that for the values of sine 1 by x, for x when it approaches 0 from either side, from x less than 0 and from x greater than 0, right? And this really shows that there isn't a definite pattern as you go, as you know, you reduce the input further and further, as so you can't really tell if the next value I give you, without calculating it, you can't really tell that it's whether it's going to be positive or negative or higher or lower in magnitude, really, unless you calculate. And it's this is a very interesting thing, which this, yeah, it's you. So the an important question, you can see an important question for me. What would be the value, the exact value of the function sine 1 by x as x tends, as at x equal to 0, the exact value of sine 1 by x? I can show it to you again. Here's the graph, and here are the values. So if anybody needs me to go back and forth, just, yeah, you can say it, and I will switch the slides. But the important question is that what would be the exact value of this sine 1 by x at x equal to 0? This is really one of my favorite functions. It's just so crazy. Yeah, go ahead.
Wouldn't it just be like undefined add 0 again?
Okay,
Its
why
denominator
would you think it's undefined then?
Because I mean the denominator would be 0, so then 1 by 0 sine of undefined would be undefined, I'm guessing.
Yeah. So yes, that's one way to think about it, right? So again, what we do is we plug in the values to the function. So we would plug in x equal to 0 into sine 1 by x. So we would get 1 by 0. Now, I think we still need to establish this, but for now we can take it as that 1 by 0 can be infinity, because, well, I think we'll come back to that, but for now we should just think that if we think that 1 by 0 is infinity, then what happens to sine of, what's sine infinity then? That's the big question. So we don't really know what sine infinity is, because as it goes, as x increases and increases for sine x, sine x just oscillates between 1 and minus 1. So, right? So what would be this? It's a good question. What do you think? What would be sine x at x equal to infinity? or as x increases further and further.
So if x approaches infinity, then since like x is blowing up and it's in the denominator, it'd be equivalent to sine 0, which would be 0. Right?
So you're saying sine infinity would be 0?
Oh no, I was like talking for this function, sine 1 over x. So
we'll get back to that. I was specifically asking
Okay.
about, how about sine infinity? What do you think sine infinity is? Again, infinity is not a number, but we should just think as sine x as x grows arbitrarily large, because infinity is not a number. We can just get closer to and closer to infinity. We can't reach infinity. So yeah, what do you think it will be as what you think sine x will become as x increases arbitrarily?
Can we say that it is anything between 1 and -1? Because since the sine function has a range between 1 and -1, we can definitely say that that's what the function will be between.
Okay,
The
good.
value
We
of that will be between.
Okay, great. So we know that that is true. We know that it's between -1 and 1, but we still don't know an exact value between -1 and 1, do we? And does it even what value? Suppose we don't know the exact value. Can we even tell what value it approaches as x grows arbitrarily large? What value does sine x approach as x grows arbitrarily large?
We can't say that either.
We can't say that. So
We can't,
right?
right?
Yeah. I think that's good. So maybe it would be reasonable to say that it's undefined then.
Yeah, I think so.
So yeah. So if we say that sine infinity is undefined, then we can say sine 1 by x as x tends to 0 is undefined. That's it. That's now that is one way to say it. That's one way why it might be undefined. But is there any other possibility besides undefined? I mean, do you think it could be anything else besides undefined? Basically the value of sine 1 by x at x equal to 0 is what I'm asking. Can it be anything besides undefined? No, nothing. So everybody thinks that it will be undefined. Yeah.
Yeah.
Okay. All right. So now, but so the problem with the way we showed that it's undefined is that we don't know whether 1 by 0 is infinity or not. Assuming it's infinity, we can say that it is undefined. But is there another way that you can reason why sine 1 by x is undefined at x equal to 0? Just another reason. Well, I think we can just use the what we say. We say that the function oscillates more and more rapidly between 1 and -1, right? The closer you get to 0. And so the value would be at 0. It's unpredictable. We don't even know what it will be based on what we saw in this table. It's the value is completely unpredictable. So it's obviously you can calculate it, but you can't predict it based on, the values you've already calculated. So since it oscillates more and more rapidly as it gets to zero, we can say that we don't really know what it'll be at zero. Yeah, that's another way to put it. But now that we've said that the value of the function sine 1 by x at x equal to 0 is undefined, what would be the limit of this same function as x approaches 0?
Maybe you can show the table again.
Yes, if you'd like to see the table. Now, what value does this approach as x approaches 0? We know that the value is undefined, but
minus
what-
1 to 1.
You think it? Sorry, I didn't hear. My bad.
A minus 1 to 1, since it could be
It
any
is minus
range.
1 to 1, but
Yeah.
that we can't say that a limit is minus 1 to 1. We have to give a specific limit. We can't say that the limit of the function is minus 1 to 1 or between minus 1 and 1. We need to know what exactly the limit is.
Yeah, I mean, so we say that the limit is a real value.
Yeah, we say that the limit is okay. Yeah. Is it a real value in this case?
Go ahead, Swara.
Can you switch back to the other slide with the table?
Yeah.
So based on this, when x is like approaching 0 from the right hand side, the value is negative 0.350, and then when you're approaching 0 from the left, it's positive 3.50. So I don't think we can say there is a limit because like left hand side and right hand side are approaching different values.
Wait, so now you're saying that their left hand side and right hand side are approaching different values. But now what does the left hand side limit approach? What value would that approach?
From the left hand side, 0.35.
Does it approach? No, it is 0.35, right? As when x is minus 0.0001, right? But does it approach it? What I mean is that what value does the left hand side limit approach as x approaches 0?
Let's consider from the left hand side. Yeah, I mean, so if you add one more 0 and still keep it a negative value, say minus 0 point, let's say instead of 5 zeros now 6 zeros 1, will it be closer to 0.35?
No, what value will it be closer to?
Right.
Is there a value that it approaches? Regardless from the side, either side, is there a value that this approaches as x approaches 0?
No, I don't think so.
No. So if you don't think so, what could we say that the limit is then?
I don't think the limit exists. I don't think there is a real value that it approaches.
Yes. Yeah, so we say that the limit is undefined or that it does not exist. Really, we should say that the limit does not exist. Now, the question is, why do you think the limit does not exist? remember, like, oh yeah, go ahead. Sorry. Remember, the value at 0 is undefined, and the limit, we're currently saying that it's not defined either. But why is the limit not defined?
Yeah, I think is that a good question to sort of leave all of us with, and I mean, it's 9:32
Yeah,
India time.
Yeah, so I just wanted to say something else, that this is a really interesting function. And if you remember the genie problem we saw a few sessions ago, where the genie turns the candle on and off, uh, can you make a connection between this function and the genie problem? That's the only thing I wanted to say. Yeah, so um, I think we can stop now. I'll just leave you with those questions. We need a compelling reason for why the limit of the function would not exist as x tends to 0. And if you happen to find anything, please put it on the group. It'll it'll stir up some really interesting discussion, I think.
Cool. I think this is good. I think we should. I too think that sine 1/x, or perhaps, you know, it's sort of cousin x sine 1/x is also an interesting function, and we should perhaps end on that particular note, that we wanted to, as a whole, make sure that we can say something consistently when we try to find the limits of these or such intriguing functions.
Yeah.
All right, so cool. So I think we have a pretty good understanding. Sorry, folks, we again have failed to time box it, but that's the nature. Uh, okay, Ms. Ruby, any closing thoughts that you may have? Okay, no problem. That's fine. I think it's really late. So again, folks, thank you very much, especially those in India. I think we have run over the time. I think the recording will be available. I'll put it pretty soon. In the meanwhile, if you guys have any questions, please go ahead. If there is anything that we have not covered, or you want us to discuss, all of us to discuss that, that would be great too. Thank you for your time, and then we'll meet on the 30th. I think we still have some time before the daytime light ends, daytime savings time ends, and so we will have 2 more sessions before that, I believe. So we'll continue with this time, and then we'll meet on the 30th.
Yeah, okay.
Cool. Thank you very much, everyone. I'll end the meeting, and we'll discuss on the group. Okay.
Yes, thank you.
Thank you.
Thank you. Bye.